Engineering-based development appraisal to general public, profession awareness, backbone of any nation, hidden works, sacrifices for development, small returns, buildings by professional engineer Suraj Singh, New Delhi. This is serial number 2. Namaskar. This is Suraj Singh, civil engineer, professional engineer. In last file, I explained to you as serial number 1 about engineering development and engineering-based development knowledge for general public. In this one, I'll tell you some more with the same types of objectives. Objectives were the world of engineering, engineering sciences, their applications, impact on the economy, health, safety and environment, quality, society, all relevant and others. Buildings, construction in Bharat, and advice to general public, civil engineering in buildings. Engineering science applies to the whole world developments. Engineering is the basis of any society. Without engineering, the human had to remain ancient. Civil engineering is the basis of all structures and infrastructures. Engineering is an art-based science with widest network. In fact, engineering is a mind religion. Without engineering, the Ramayana could not be completed. In Mahabharata, building was set on fire. Without engineering, nothing is possible. Yet the professionals are most unbeneficial and society is unaware about their sacrifices and their issues. No politics can sustain the national advancement without the role of engineering. Engineers can change the national power and states in the world. All other professions shall be worthless without the contribution of engineering in the global scenario. Engineering travels its journey from a dream to a made-up project. A dream coming true, and it comes true, it has come true, it shall be coming true. Engineering is the heart of the nation, engineering is the heart of the world. Engineering is the heart of the society, and engineering is the heart of development. Vishwakarma is the master. Engineering is a god of engineering. His knowledge comes to every engineer. Vishwakarma, who built the Vishwa, who built the world, who is the work of the world. Vishwa means world, Karma means work. The public of the whole world living on the earth has been developing various nations as well as the globe. The contributions from all fields of human life are responsible to make it, but a considerable contribution comes from the fields of engineering of all disciplines. Without the contributions of engineering, the life shall cease. The history is full of various legends of engineering all over the globe. Though there was no engineering education in those days, yet the minds were full of engineering knowledge, inculcated either by the God gifts or by the clan works inherited from ancestors. Taj Mahal is one of the examples. Qutub Minar is another example, and many buildings elsewhere around the world. Engineering contributes from the manufacturing of a needle to the space vessel. All systems are running based on any branches of engineering, any branch of engineering. Engineering involves a part of art, a part of applied mechanics, a part of applied sciences, and the health, safety, and environment, with the assistance of all codes and the national and international laws. Engineering is a very complex term in this age, as contribution from various engineering disciplines are required and are available as well to accomplish any small task or manufactured piece. Civil engineer takes the lead at the initial stages and contributes to the full execution of any project. In continuing from the previous one, that was serial number 1, and I had to explain about soil engineering. I explained it a lot. Again, I repeat for your information. Soil engineering is a very vast subject, but for the information of the general public, I have tried to brief about it. The nature of the soil is not fully known yet. How shall the soil conduct in its performance is not absolutely understood. No soil engineer around the world can guarantee the resistance of the soil to any definition. Just like when any earthquake shall occur cannot be predicted, the same applies to the complex soil structure. Yet, an advance has been made in the field of engineering for ordinary building constructions. Generally, the following types of soils are met during surveys. The soil could be sandy or sand, If the soil is sand, it may be dry or wet or moist. The soil could be clay mixed or silt mixed. In Bharat, India, at so many locations, black cotton soil is also available. That is clay. Sand comes under the classification of granular material, while clay and silt comes under cohesive material. The availability of sand is better than clay or silt. Even moderate density sand performs better than clay. The soil investigation is very significant activity. It may cost some amount, but if the design is experienced, the investigation can be done by the site, on site by visual experiment of sedimentation. Excuse me. For moderate small buildings, it's not very essential to get into picture the soil investigation laboratory, since the laboratories are not available everywhere. I'll just quote an example of construction of Red Fort in Delhi, Lal Killa. In those days, there were no technique, no equipment in our country. The king had started the construction, and after excavation and foundations, etc., excavations and preparations of the foundation, etc., the person responsible, technician or architect responsible for this disappeared for many months, say about 24 months. King was angry. He was not feeling happy because his project stopped. After 2 years, the guy turned up. King called him and he was presented in his king court. The guy answered. When the king asked why you disappeared, because he wanted to punish him. The man stopped the project. Man answered to him, Your Honor, Your Excellency, I disappeared because this is sandy soil and I had excavated. I had to compact it. I could not compact it because of this. Now after 2 or 3 years, due to rain, it is self-settled and I can work on it. The king felt very happy and awarded the person that he did his good job, keeping his life at risk. This is what our past was. A loose sand is not advisable to be used for foundations as it is too dangerous. If the soil looks very fine, it may be silt or clay. If wet soil rolls into thread using fists, it is definitely clay or silt family and not supportive for foundations. Without special designs, in general, good soil strength is defined in terms of its bearing capacity and shear strength. There are two types of bearing capacities. One is ultimate bearing capacity, while the other is safe bearing capacity. Every soil should have a good working bearing capacity. To find out the working bearing capacity, a safety factor is applied to the ultimate bearing capacity. The detailed reports, if conducted by any professional material testing laboratory, as the practice should be, a value of bearing capacity is recommended by the soil engineer along with the type of foundations most suitable for the soil in consideration. Boreholes are drilled to extract soil samples in the form of cylindrical cores. Then various tests are conducted and the observations made, based on which the recommendations are made. Many types of tests are conducted: shear strength, water level, water flow, soil penetration, soil settlement, soil physical properties, soil chemical compositions, soil electrical resistivity, soil thermal resistivity, and many more. The most important for an immediate decision is the value of the bearing capacity, based on which the type of foundation has to be classified. A problem is always seen when the soil is clay or silt, and depending on the vicinity of the natural water level, soil may be penetrated by the soil water from time to time or during seasonal variations. It is recommended in general cases that the bad soil is to be removed and then soil improvement is to be carried out by filling good granular or friable soil free from deleterious materials. Based on all these information, whatever we have or we could have, whether the foundation should be isolated spread footings or rock foundations, rock footings, foundations or strip beams, connected a proposal for the piling. Even piling can also be there, which is a very big one. The sole purpose of the soil is that the loads coming from the structures have to be transferred to the soil below using the soil bearing strength or capacity. Foundations do not take the loads but transfer the load to the soil. There is a misconception that the foundations take the loads. Foundation is a medium to transfer the loads to the soil below that further spreads the loads onto the soil lower stratum. Isolated footings are separated, independent, rectangular or square-shaped concrete foundation from which columns are taken upwards. These footings transfer the loads to the soil beneath through an even concrete layer called blinding concrete. In case of weak soils such as clay, the raft foundation is recommended. Raft footing transfers the load of structures from all columns of the building as one unit to the soil beneath. By the provision of raft foundation, the settlement of the building remains uniform in long run. That is responsible to prevent the possible cracks and undue stresses. By provision of raft foundation, the chances of water rise into the buildings are reduced to considerable extent as concrete is to a much extent impermeable material if properly designed and mixed or produced. The provision of raft also helps the building resist the earthquake forces to a better extent than isolated foundation. Where the soil is too weak, on which the heavy loads cannot be transferred, the foundations are to be taken to a strong layer below at any reasonable depth. The piles serve that purpose, to transfer the loads from the columns to the hard stratum. Another solution is to provide the beams connecting all the columns so that all the beams act as a unit to transfer the loads uniformly onto the foundations and then to the soil. These beams then convert themselves to columns virtually during the occurrence of the earthquake. These beams can reduce the effect of the earthquake on these structures. Piles are in general, not required for ordinary few stories buildings. Until the soil is too weak, the foundation concrete also requires protection from the soil due to soil possible containing many inorganic chemicals or organic impurities that may be responsible to contaminate the hardened concrete. There is also a chance of moisture move within the surrounding soil and affect the concrete in long run, so that the concrete protection cover is badly affected. Concrete protection cover is defined as a distance between the reinforcement and the face of the concrete from all sides. Cover should be sufficient in all respects for the protection from moisture as well as for fire or thermal resistances. Covers are generally manufactured from rich concrete mix. Plastic covers are used in lieu. For meeting this requirement, a bituminous membrane, either preformed or site applied, is used around the foundation concrete up to the plinth level or first ground level. Another protection is required for the protection of the bituminous layer to protect it from the soil backfill possibilities of puncturing the membrane. A bituminous or other board takes a good care for this requirement. Now, before explaining further, I shall like to show you certain drawings that actually shall tell you about the members. Now, here's a drawing. So, here's a drawing on AutoCAD that is showing you a building in 3 dimensions. This is the building. This is in 3 dimensions on AutoCAD. You can see this is in hidden form. You can see this like as it is, and if you see, I'll show you this. This is the construction of this drawing phases, and you see these vertical members are called columns. These members are columns. In technical language, we call them RCC columns or simply columns. And this is, if you see here, I just make a build-up of this. Let us see, I have blown it up. You can see this now. If you see this blown up, zoom one, here are horizontal members. These horizontal members are called beams. These horizontal members are called beams. Also, where you see you can see this hand sign. These are all beams. These are all beams here, and these are all beams where hand sign is moving, palm sign, and these are all beams. These are all columns. This is column. This is column. This is column. This is column, and this is three-dimensional structure. And if you go to this one, this is wired structure, means without hidden form. This is just showing the wire frames. These are all wire frames in three-dimensional form. This frame shall be hidden, but this is the construction procedure and how building is constructed. You can see all this entry, and these are various floors and all line work, wire framework. You can see the other floors also, same structural. You can see this is the staircase here. All this shall be hidden when I apply my command of hide. Here I am applying the command here. This will, and this is here hide. See, it will hide it, and you can say after some procedure it's hide hidden, and this is the hidden building now. You can see this way also. You see, this is hidden, and I'll show you various poses of this now. See, this is in all directional poses of this building, the structural work, all four directional poses, which is very, very important from understanding viewpoints. You can see this. Now I'll hide this. You will hide, and after some procedures, it will hide up. You can see this now. It is hidden, completely hidden. And hidden means wires are hidden, wire frames are hidden, but weave is visible. This is one directional. This is the other directional. This is this directional, and this is the other directional. And this is what is engineering designs and engineering drawings. This is after analysis the structures. This is very, very important. I'll try to show another drawing as well now, and I'll open another file. Let us say I'll show you from house plan. You can see this plan is coming up. This is the plan. You can see now the plan. For example, this is the plan. This is two-dimensional, in x-y axis. Different types of planes are shown, and various stages of these are shown here. Various stages. I'd like to show you other one also. Let's do another drawing. You will understand very well. Let's say house plan. You can see this. You see these elevations here. These are elevations in architectural form. Left elevation, front elevation. These are the elevations here, and right elevations here. And these are very important from engineering viewpoint, production viewpoint, from so many viewpoints. And if you understand this, it will be easy for you to get the meaning of engineering that I'm talking. I can show you another one also. One more drawing. Let us see, try to understand this. I'll go to some other drawings that are, let us say, I'll show you one of my friends that have prepared. This is another drawing. It's a very simple plan, very, very simple plan. Just one plan, and somebody wanted me to help him for this, and I did it in Abu Dhabi on one of the projects. It's just simple, and similarly I'll show the other one as well. It's also very, very simple. Just for some of my friends, Varghese. Just for him. Just see this now. This is a plan. This is the plan. This is another direction of the plan. Another direction of the plan. And this is also another direction of the plan. These are all elevations here. Elevations, 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 and elevations. This is elevations here again. So I'll again go to narration, because narration is more important than anything else. So I'll explain to you now what I was still telling you before. That is an important one. And I close the drawings now. Drawings are closed. And this last one. And I'll now speak again to our civil. This is now. Then the most significant design activity is the design of the frames of the structures. A frame, just I explained to you before in these drawings, a frame comprises various members of the buildings in different areas depending on the spans and the size of the building. Generally, the vertical members are called columns, as I showed to you, while the horizontal members are called beams, I showed to you. I displayed to you on the drawings. Excuse me. The columns connect from story to story, while the beams connect one column to another column. Every building comprises of many mains and cross frames. These frames receive the various types of loads as indicated before from the slabs, through the beams and then to columns from top to down, the columns to the foundations and then to the soil. The job of the designer is to contemplate the best positioning of the frames to meet the architectural requirement of the building, simultaneously allowing the openings of various modern services of all disciplines, namely electrical, plumbing, mechanical, air conditioning, firefighting, internal and external drainage, rainwater discharge, thermal insulation, telecommunications, and so on and so forth. Designer has to deal in coordination with the definite requirement of all subdisciplines as well as produce the defined architecture. This is very important activity as it is generally overlooked by the architect agreeing, taking the responsibility themselves or himself without giving a thought of smooth constructability. The architect sometimes poses problems for the designer by imposing his own selected sizes of various framing members without keeping in view the probable adverse results in the long run during the building service. But in the advanced building construction, all factors are considered mostly during the initial design stages, as most of the stereotype designs are already available for major projects, but the problem lies with the small, varying architectural buildings when the client is not ready to pay for different services designing. It is suggested that the owner of the client should insist the designer to take all the necessary factors at this stage. The designer definitely uses the available software for producing the structural analysis to find the bending moment, shear force, deflections, etc. for all members. All the forces such as dead load, live load, wind load, seismic and earthquake forces, etc. are considered during analysis. Varying loads patterns are checked. Three-dimensional modeling is generated that gives thousands of stresses and the indications of the forces in all the members. All the reached stresses are checked to the code requirement as well as the optimization of the materials so that no redundant material is used. Advice is that the least reinforcement should be used as well as the stresses should be satisfied. The least concrete should be used as well as the stresses should be satisfied for the betterment of the building and economy of the finance. The frame should be flexible enough to conduct as a damping medium for the vibration of earthquake. Natural frequency of the frame is to be checked and maintained according to the requirement. The deflections are to be kept within limits. The no-node bearing walls are to be designed to be inserted later after the construction of the frame. If the brick or block work walls are to be used. If the RCC walls are to be used as shear walls, the walls are to be constructed as part of the frame construction. The designs are to be done as per the requirement. I have seen in Bharat that all buildings that are built or raised along with the are done along with constructing walls of bricks that being not in line with the earthquake resistance design requirements. When the walls are constructed prior to the slabs or slabs is rested on the walls, the purpose of the RCC frame is absolutely defeated. During the earthquake, the brick walls shall not help the frame to vibrate and move, dampen the vibrations. The walls make the frame rigid to a much desired extent. It is advised that the owners themselves take care of such operations, as a contractor or builder shall like to save the time and efforts by doing their ways. The owner has to check self in case the services of an engineer are not hired. Though it is strongly recommended that the services of an engineer and a structural engineer is a must to save a lot of money by way of saving of reinforcing steel as well as undue thickness of RCC. Engineer is the expert of structural design and supervision. Owner should draw benefit of saving money and time by engaging the civil and structural engineers. Exclusively dependence on the architect is not advisable, as architect has his own discipline. Architect, according to codes of ethics, should not encroach the other professionals, which is against everything, and also it's a civil crime. An owner should be directly advised that he either pay for the fees of a structural engineer, the architect must transfer to the structural engineer, or he should appoint a structural engineer. The owner should appoint a structural engineer for his own purpose, so that a structural engineer has to take the responsibility. Most important point here is to mention is that constructability. What is constructability? There are so many viewpoints. Now you are going to construct a building. First of all, architect makes a plan or a structural engineer makes a plan. Okay, generally architects makes a plan. That plan shows the orientations of the frames. Those orientations should be right. Frames means location of the columns and beams are shown. Here column location is very important, because architect has to include his walls, his rooms, everywhere. Now there is a possibility that many columns could clash. Columns are located according to architect's requirement and also according to structural requirement. Architect says, no, I want the column here, while the structural engineer recommends somewhere else due to stresses requirement, satisfaction of the stresses. So this kind of clashes generally occur, and this have to be resolved. Designs should be such that architectural work and the structural engineering work should go in line together without any dominance. If a structural engineer says, no, I cannot fix the column here due to so reason, but the architect says, no, my wall is coming here, you have to make the column in line with the wall, or you have to shift your column. This means whole of the frame is going to be shifted. Columns, that's the reason what I'm saying constructability means your design should be such that there should be no problem in the construction of that. Construction should be easy, drawing should be clear, so on-site execution should be easy, no more additional money is to be spent, no more additional safety factors are to be included. That type of constructability criteria should be jointly approached. This is very, very important for both the professionals of architecture and engineering. As far as supervision should be easy. Means I don't want to see for one work 10 drawings if 3 drawings are sufficiently giving the results, giving the guidance. Details of in drawings, for example, steel reinforcement detail, it should be clear on the drawings. A steel fixer or a steel bender should know easily what he has to do, how much steel he has to cut and how he has to fabricate. Similarly, a carpenter or a carpenter foreman of shuttering should know how he has to erect the shuttering so that it is easy, is the most optimum time, and with the minimum formwork material utilized. That is the way constructability works. Personality factors, egoistic factors should be set aside. engineer and architect have to join together to produce a good building. Clashes should not be encouraged. Unfortunately, this has happened, this has been happening, and this will happen because of architect's dominance. Architect thinks that he is the dominant in building construction, while without the support of the structural engineer, he can do nothing. This is the fact. There's no question of criticism of anybody. Aim is the target is a good building, a strong building, a safe building, an economical building. All these are our aims. These aims must be adhered to. Unfortunately, this is not happening. And there's another problem also. So far, in our country, there is no mandatory provision that engineer must be utilized or must be deployed on construction and design of buildings. Architect Act is there, Architect Act 1972, which defines designers. Now, designer here is designer of architecture, which is not actually written in the Act, but that is understood. Architects have constructed the meaning as they are the designer of everything. Architectural designer, structural designer, services designer, everything. They have taken it as a sum of all the services which are to be rendered for the construction of a building, design and construction of a building. This misconcept has been misused so far since 1972. Still, yet there is no mandatory provision in any other act where engineer is required. There is registration of engineers by certain institution like IEI, that is Institution of Engineers India, but that is voluntary. No act specifies that there should be a chartered engineer must. There's nothing like that. If you are a chartered engineer, you can give services. If you are an owner, you can utilize the services, but there is no mandatory provision that there must be a chartered engineer or there must be a structural engineer. There shall be changes according to National Building Code 2005, which has been approved, but these incorporation into the regulatory bodies bylaws have not come yet. It may take few years. Some have started this, some have not done it. There is also a pending draft of Engineers Act in the Parliament in 2008 that also is in the draft stage. If government survives or may not survive, this will take, I think, another Lok Sabha will do it. And it has been a problem for the people that people don't know what to do, and that draft is also not very strong. It simply gives the definition of engineer. Any person who is a graduate in engineering is called engineer. They will be registered as engineer. They will not go to high profile registration like chartered engineer registration or professional engineer registration. Just like in the international arena, it is happening. Professional engineers are registered according to a light registration, but these